Hi, hello, welcome to Completing the Square. This is going to be the fourth lesson in Unit 2, and we're going to talk about how to create a perfect square, like what we talked about last time. Alright, so during this lesson, you should be learning how to convert a quadratic from standard form to vertex form of a quadratic, and the process behind that is completing the square. Okay. So just some quick vocabulary. Perfect square trinomials is a trinomial in which two terms are positive perfect squares, and the third term is the square root of each of those terms multiplied together and doubled. This is what we talked about last time. You're going to see it on quizzes and tests, so make sure you have that's an awesome star there. Okay, completing the square is the method used to translate a quadratic into vertex form. Vertex form is just a form in quadratic where we can easily see the vertex. HK is my vertex, so we get H comma K. Notice here my H is a negative, and then in the vertex it's positive, so know that that's going to be different. We're going to have opposites there. The vertex is the point in which the graph changes direction. Okay, we like the vertex. It tells us a lot of stuff. The axis of symmetry is a line that splits a quadratic in half. So if I have my quadratic right here, that's the line of symmetry. It's going to fold it. It's going to go through the vertex. Okay, let's get started. Alright, so we talked about last class. We talked about perfect square trinomials and just perfect squares in general. We know that if I'm using my algebra tiles or my factoring tiles, I know that these are x by x or x squared. These are x by 1, so we'd say the area is x, and we know these are all 1 because they're 1 by 1. Okay, so we know that when we're talking about perfect squares, I know that these have to be the same on both sides, my length and width, to create a square. What we're going to do today while we're completing the square is we're going to be given a trinomial that's not a perfect square. And we're going to have to figure out what we can do to make it, to create a perfect square. And I'll help you show you how to do that. Okay. So to change from standard form into vertex form. Alright, that's what we're doing when we're completing the square. It's just that process of transforming a quadratic from standard to vertex. We call it completing the square. We use this to find the vertex form of a quadratic because we want to see what the vertex is. That vertex form can tell us about the shape and kind of location of a quadratic or a parabola on the plane. Alright, let's look through the steps. So first, move all terms without an input variable. So anything that doesn't have that input variable, we call that our x. We want to move anything without that to the other side. So if it's on the right side, we want to move it to the left side. If it's on the left side, we want to move it to the right. We want to only have input variables or x's on one side. And we move it to that side that has the output variable, or y. Remember, f of x is our fancy y. Okay. Next, step 2 is divide through by the coefficient of a. That's the number in front of the x squared term. So we're going to divide everything by that. Step 3, take half the coefficient of x, number in front of x, and then we square the result of step 3. Next, so these steps right here, 3 and 4, that is what we did to check for a perfect square. We're just going to write up the side here. Those are the same steps that we did last time. Step 5, we add that result to step 4. We add that to both sides. We add step 4. Step 6, we can now complete the square by factoring the squared variable side. So the factor should exclude this result of step 3. That's kind of that factoring of that perfect square that we saw last time. And the last step, step 7, is we're going to isolate our output again. Okay, let's look at this. Alright, we can stick with green here. So I'm going to look at this equation. I'm going to say, okay, I'm going to look at the side with my input variables. That's my x side. I'm going to move anything that does not have an input variable or an x. I'm going to move it to the other side. So I'm going to subtract 2 from both sides. So what I get is y minus 2 equals x squared plus 6x. Okay? I'm going to divide through by my a value. Notice my a value is just a 1. It's just that term in front of the x squared. Nothing's there. Dividing by 1 doesn't change the shape of this at all. Next, I'm going to take that term, or that coefficient, that number in front of the x value, the coefficient of the x term, and I'm going to divide it by 2. This is that part of how we identified a perfect square. So 6 divided by 2 is 3. Then I take that 3 and I square it, and I get 9. My next step here is I'm going to add this 9 to both sides. Okay. Now that I've done that, what I just did is I created a perfect square on that right side of the equation. So I'm going to simplify the left side. So I have y. Let's kind of keep things in order here a little bit. So I get y. Negative 2 plus 9 gives me a plus 7. And now I can factor this right side, and it's going to factor to be x. And whatever I got when I divided by 2. So that's that 3 right there, plus 3 squared. So we just created a perfect square. The last thing we have to do is we want to get y by itself. So I'm going to minus 7 from both sides. When I do that, I get y equals the quantity of x plus 3 squared minus 7. And now we're in vertex form. Notice here, we have h, we have k, so we could say the vertex is negative 3, negative 7. Okay, so now we're going to do a now you try problem. I want you to convert the following quadratic from standard form into vertex form. Be good if I put that there, huh? Okay, so pause the video, try this out. Notice that my a value is not 1 here. Okay. Alright, let me show you how I would go about this. So the first thing I would do, let's keep it as green. I'm going to move that term that does not have an input variable x in it. So I get 2x squared minus 8x. Those 3's cancel out, equals y plus 3. Notice I'm going to leave some space here. I like to leave space because I know that next step I'm going to have to add something to create a perfect square. You don't have to. It's something I like to do to help keep myself organized while I'm working through this problem. The next step is, since my a value is not 1, I have to divide through by that 2. So what I get when I do that, 2 and 2 cancel out, so I just get an x squared. Negative 8 and 2, I get minus 4x equals, and we're just going to leave this as y plus 3 divided by 2 over here. Okay, there's no need to simplify that or break that down at all. My next thing is I'm going to take that middle term, I'm going to divide it by 2. I get a negative 2. Then I'm going to square that negative 2. I'm going to keep that negative in parentheses. When I put that in a calculator, I'm going to need that to show that it's a positive 4 and to say that I'm squaring that negative value as well. And then I'm going to add that 4 to both sides up here. Okay. So now this is, I guess it's really right here that we're adding it. Okay. Now that we have that, I can factor, in this case, my left side to be x. So I'm factoring this right here. I'll just put a box around that so you guys can clearly see I'm factoring that that side right there. X minus 2 squared equals y plus 3 all divided by 2 plus 4. Now I'm just going to simplify. I'm going to solve for y here. I'm getting y by itself. So the very first thing I'm going to do, I'm going to subtract 4 from both sides, and we get x minus 2 squared minus 4 equals y plus 3 divided by 2. Okay. Next, I needed to multiply both sides by 2. When I do that, those 2's cancel out, and I get 2 times x minus 2 squared minus 8. Notice I'm distributing this 2 to everything. Okay, equals y plus 3. Then I'm going to subtract 3 from both sides. When I do that, I get 2 times x minus 2 squared minus 11 equals y. There is my answer. So you should get 2 times the quantity of x minus 2 squared minus 11 equals y. Alright, so that's the end of the lesson. If you have any questions or you need any help with anything, please come and talk to me or a tutor, and we'd be happy to help you with this completing the square concept. Have a great day, and we'll talk to you later. Thanks.